So, Mars is the king of volcanoes. All right. Now, next surface feature I want to talk about is a canyon. Okay, if we look back on the, let me bring the pictures back up. There we go. If we look back on this picture right here, if you look right in the center of Mars here, going across, this is a canyon, okay? Now, this canyon is stretching almost entirely across this picture right here. So what does it tell us about that canyon? What's this canyon like? That's right, it's very, very big. So Mars doesn't just have the biggest volcano in the whole solar system, it also has the biggest canyon in the entire solar system. And it's called Valles Marineris. Okay? Valles Marineris. Let me show you a closer up picture of it. There we go. Valles Marineris, and you can see the spelling of it right up here. That's V-A-L-L-E-S. Marineris, M-A-R-I-N-E-R-I-S. Valles Marineris. That is the biggest canyon in the entire solar system. It is way bigger than the Grand Canyon. I got some numbers right here. It's 10 times the length of the Grand Canyon and about 3 times the depth. So it is very, very big. Now, the shape, though, is not the same as the Grand Canyon. Because does anybody know what formed the Grand Canyon? What cut the Grand Canyon into the earth? What made the Grand Canyon? A river. Yes. Yes, it was a river. So a river, specifically the Colorado River, made the Grand Canyon. But is the Grand Canyon just basically a straight line like this? So this canyon's like a straight line from one end to the other. Is that how the Grand Canyon looks? No. The Grand Canyon basically loops back and forth because it's made from a river. Do rivers typically go in a perfectly straight line like this for thousands of miles? No. No, they don't. So that tells us that this particular canyon was not formed from a river. Okay? This particular canyon, instead of coming from erosion, came from a type of geological activity. It's just a particularly rigorous form of geological activity that happened a long time ago on Mars. Now check this out. I'm going to go back to this picture right here. On this picture, the canyon is right here. That's Valles Marineris right there. It doesn't quite look as big on this picture because everything's been flattened out, but that's the canyon. And if we look right next to it, remember, what are these things right here? These are volcanoes, okay? This whole region right here has a lot of volcanoes on it, and it's called the Tharsis Rise. They say the Tharsis Bulge right here. That's the same thing, but it's the Tharsis Rise. The important part is there were a bunch of volcanoes right here. And so that tells us that a lot of hot material was rising in that location, in the Tharsis Rise, in this little dashed circle. Now, what happened there was so much hot material was rising in this area with all the volcanoes that this whole part of the crust stretched out. It was pushed up. And when that part of the crust pushed up, the part of the crust with the canyon sunk and cracked. Okay? So essentially, this canyon is a big crack that opened up when a part of the crust sunk as a part next to it rose up. looks like I have a question here. There we go. All right. Now, so the canyon here is more of a stress crack than the canyons on Earth. Okay, but it is by far the biggest canyon in the entire solar system. Okay, now, here we go. We said that the entire surface has rust mixed into the dirt and rocks. So the question I have is, what makes iron rust? Moisture, water. Some people are saying oxidation. That's true in a technical sense, but the easiest way to get iron to oxidize or rust is to introduce water to it. Now, looking at this picture I have of Mars, do you see water all over the surface of Mars here? Do you see a lot of water on Mars? No. There's not a lot of water on Mars. So what we have to do is figure out how did it rust. But here's the thing. Check this out. Let me show you a close-up picture of part of the surface of Mars. Check this out. Look at this smooth, sweeping back and forth motion here. Can anybody figure out what this is? What is this a picture of? Yeah, it's water erosion from a river, okay? This is a river, but do you see any water in that river? No. But it turns out that all over the place, all over Mars, there are dried up riverbeds, okay? So Mars has dried up riverbeds all over the place. Here you can even see one that swoops back and forth and then spreads out, forming river deltas. And then it looks like it just stops. So what might have been over here on this side of the picture? What might have been over here if we've got a river spreading out into river deltas and then just looking like it disappeared? Yeah, that could have been... it could have been a lake or a sea or an ocean, a large body of water. So what we're seeing here is the end of a dead, dried up river. So what I'm getting at is that Mars used to have rivers and lakes and seas. In fact, and somebody mentioned this a little while ago, it is thought that possibly the entire northern lowlands, because they were a lower elevation than everything else, could have collected a lot of that liquid water, and the entire northern hemisphere could have used to have been an ocean. It could have used to have been an ocean. Okay? And there's some evidence that a lot of rivers end as they get to the north. So, let me put myself back down here. Yes, so what I'm getting at is Mars used to have all of those things. Does anybody know why it doesn't anymore? What changed on Mars? Well, remember, we said that the inside slowly dried up. That at least partially has to do with the temperature. What has been happening to the temperature on Mars over time if the interior of its planet has been cooling off? Cool, yeah. Mars now is too cold for liquid water, okay? Mars cooled off. It used to be warmer on Mars, and now it's not so warm. So the average temperature on Mars is about -10 degrees Fahrenheit, which wouldn't kill you but it would be very uncomfortable, and that's below the freezing point of water. So on average, the water should be all frozen on this planet. And we have to make sure that makes sense because the atmosphere of Mars is mostly CO2. It's mostly carbon dioxide, and just like Venus. And what did all of that carbon dioxide do on Venus? What did all the carbon dioxide in the air on Venus do to the temperature on Venus? Yeah, it gave it a strong greenhouse effect, and that caused the temperature on Venus to get very, very, very hot. So why is it that Mars is cold? Like I said, their atmospheres are both mostly CO2. But remember, Mars is much smaller than Venus. So what does that mean for the gravity on Mars? It's much lower. And that means that Mars isn't as good at holding gas down. And that means that the atmosphere of Mars, even though it's mostly greenhouse gas, the atmosphere itself is extremely thin. So it doesn't matter if Mars's atmosphere is mostly greenhouse gas if it has a very, very, very thin atmosphere, because then the greenhouse effect can't trap heat very efficiently. So Mars is below freezing on average. So where is it? Well, if I said that Mars used to have rivers and oceans, and seas and lakes, that means there was water everywhere. And if you freeze water, it doesn't just teleport somewhere. So where is it? Well, actually, we have found water almost in giant swaths of the surface of Mars. There's water all over the place here, but you can't see it. So where is it? Where is the water all over the surface of Mars if you can't see it? There's a pretty simple explanation for where the water went. Underground. Some people mention the poles, and there is ice at the poles, but I'll get to that in a second. But essentially, as the water froze, it kind of seeped into the ground. So in a large area throughout most of Mars, if you dig under the ground, you will hit water, but it will be frozen, and it will be mixed with dirt and rock. So it might be very hard to get enough to work with. That said, every once in a while, when a crater hits, it exposes some of that frozen water to the sunlight, and that causes it to slightly melt. And I've got a picture right here where you can see these little streaks on the edge of a crater. And these probably came from a little bit of that water melting and flowing down the side of the crater before it refroze. So the exposure to the sun caused it and the low pressure caused it to liquefy for a brief amount of time before it refroze. Now, so a few of you guys mentioned the poles, so let's talk about those for a second. Because, yeah, the easiest to find water in these images that I've been showing you guys is at the polar ice caps. So just like Earth, Mars has polar ice caps. One up in the northern pole and one at the southern pole. However, it is so cold on Mars that these ice caps are not just made of water ice. They're also made of a different kind of ice you probably have heard of called dry ice. Okay? Dry ice. And it turns out that the water ice is at the bottom of the ice cap, and dry ice freezes on top of it because you need an even colder temperature to make the dry ice, and it took longer for the planet to get cold enough for the dry ice to form on top of it. But here's my question. Does anybody know what dry ice is made out of? Because dry ice is not just a different kind of water ice. It's made out of an entirely different substance. Does anybody know what dry ice is made out of? Carbon dioxide. That's correct. Dry ice is carbon dioxide. And is there a source of carbon dioxide on Mars to make this dry ice? So the original water ice probably came from all of the water that we were talking about before, but where did this dry ice come from? Where's it getting this CO2? Yeah, so it's the atmosphere. The atmosphere. So essentially, the atmosphere on the surface, the atmosphere of Mars, remember we said was CO2. So some of that CO2 has frozen onto the poles. All right. And some people are asking, oh no, that's fine. Okay, so, somebody way long ago asked why the northern pole looks bigger than the southern pole. And that is, it's just because of the time this picture was taken. So these poles don't stay the same size. This picture was probably taken when it was winter in the northern hemisphere. So that North Pole up there is experiencing winter. And what happens to the temperature in winter? It gets colder. So when it's winter on your pole, the pole has more CO2 frozen out of the air, okay? And then when it becomes summer, that CO2 at least partially melts and sends the CO2 back into the air, and it freezes onto the other pole, okay? And that actually leads to a kind of a strange thing happening. Essentially, when a lot of CO2 freezes onto the poles, about a third of the atmosphere gets frozen, okay? So every winter for one of the poles, a third of the air goes away on Mars. And for a long time, we didn't understand what was happening to the atmosphere of Mars until we looked at those poles, okay? Now, yeah, so that's all I have to say about the poles. Let me check my notes. Want to see if there's anything else I need to talk about. Okay, some weather. Mars doesn't have a thick enough atmosphere to really form clouds most of the time. Every once in a while there's wispy clouds, but for the most part there's no clouds, so there's not a lot of weather. But there is wind in the atmosphere. So the atmosphere does have wind. And the whole surface is covered in dirt and dust. So when that wind blows, you get frequent dust storms. So there are massive, massive dust storms on the surface of Mars. Okay? And those dust storms get so large that they sometimes cover the entire planet. So that's something that we're going to have to be careful about when we send astronauts to Mars, because you don't want to be in these really strong dust storms. And occasionally those dust storms will cause dust devils. And if you don't know what a dust devil is essentially a tornado full of sand. And you really don't want to be in a tornado full of sand, because that could rip your skin off, right? And obviously we aren't going to have astronauts just standing around without a spacesuit on, but those dust devils can also destroy a lot of materials, so they could destroy a lot of the equipment for those astronauts. So watch out for that. No, one question I should ask about that. We have dust storms on Earth, But we don't have dust storms that go over, the entire planet. And the reason for that is that large portions of our surface are covered in both water and vegetation. So there's no vegetation on Mars to stop these dust storms from forming. So that's why the dust storms can get so large and so bad. Okay?